Okay, good morning to the students. Now, first of all, subscribe this channel. Those who have not subscribed the channel. Okay, today we will discuss that color coding of carbon resistors. In last lecture, we have done that temperature dependence of resistivity, thermistor, and semiconductor. Sorry, superconductors. Okay, now today we will discuss that color coding for carbon resistors. This is very important article for the examination point of view. 1 mark, 2 mark question is definitely coming from this. Okay, in the form of a numerical. Now, why we are using color coding for a carbon resistor? Now, simple answer is that it is used to find the unknown resistance. We can find out the unknown resistance with the help of carbon coding. Okay, na? Now, what is a method to do this? First of all, you have to learn one line that these colors. Okay, now your question will be in your mind that how you will learn these colors. By simple one line you have to learn that BB Roy, Great Britain, very good wife, good son. Now, what is the use of this line? You will see that BB, okay, B here black, brown, red, orange, yellow, green, blue, violet, green, and white. Okay, and why this good sun we are using? These are the colors. Okay, that gold and silver, no color. Now we will discuss. You will first of all you will make box like this with the help of this line: BB Roy, Great Britain, very good wife, good son. Then write down the color name, then figure. In front of black 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, then multiplier. 0 is there, 10 raised to power 0. 1 is there, 10 raised to power 1. 2 is there, 10 raised to power 2, 10 raised to power 3, 10 raised to power 4, 10 raised to power 5, up to 10 raised to power 9. Now next column is color. Color you have to use gold, silver. We will discuss that how you will utilize this box in numericals. Okay, we will discuss that step by step. Now first of all, gold is there. If the gold in mentioned there, then tolerance is 5%. If silver mentioned 10%, no color will be 20%. Now we will come to our next how you will use this. First of all, you have first step is that color of first two strips, means you have to choose first two strips colors. Okay, then next you have to write down the number of zeros. Then fourth means which color is there, relatability is there. Okay, now with the help of numerical we will discuss that. Suppose that this superconductor was there and you have to find out the resistance of this resistor. Then how you can find out? Now they mention that two strips they mention. Now first strip color is red and second strip color is green. Then find out the first two figures. Now red color figure is 2, so you will write down 2 here. Second is green, write down green figure is 5, you will write down 5. First two strips. Then third you have to calculate number of zeros, then multiply. Third one is yellow. Now sees that number of zero, yellow color having number of zeros 10 raised to power 4, so multiply 10 raised to power 4. Now last one is tolerance. Now golden, plus minus golden 5%, then you will write down 5. Means first two strips color figure you have to write down: red having figure 2, green having figure 5. 25 will be there. Then multiply. Third, that multiplier you have to use. That multiplier of yellow is 10 raised to power 4, 10 raised to power 4 you will write down, plus minus their tolerance. Golden having tolerance 5, then 5%. Now the numerical can come in second form also, like they will given you this, means what they will ask, what is the color coding of the strips of carbon resistor having the resistor of 25 multiply 10 raised to power 4 plus minus 5%. Then you have to write down the colors. Then how you will write down the colors? Now for 2 what was red, you can write down red. On 5 what was green, then you write down green. Okay, then comma. 10 raised to power 4, you will write on yellow, and 5% is there, you will write on golden. Like this one. What is the color coding of the strips on a carbon resistor of resistance 200 ohm plus minus 20%? Now 2, you will see that on 2, what was there? Red, you will write down red here. Okay. 0, on 0 what was there? Black, you will write down black here. Okay. Now section 0. Now multiplier. Okay, means on multiplier what you will write down? 10 raised to power 0 is 1. Okay na. Then on 1 what was there? Brown, then you will write down brown. Okay, plus minus 20% is there, means on 20% no color, so need to write down, or you can write down no color. Okay, so this was the color coding of carbon resistors. Okay, now next was we will discuss that combination of resistance. Now there are two combinations of the resistance. First one is a series combination and second one is a parallel combination. Now first of all we will discuss about series combination. When we are set that cells are in series combination, when if a current is passed through each of the resistor and potential difference across each is different, then the cell is said to be in series combination. Okay, it is said to be that grouped in series if same current pass through each resistor and potential difference is different. Means in series combination you have to remind that potential difference is different and current is same. That figure is there. Suppose that these three resistors are there, R1, R2 and R3. Their potential difference is V1, V2 and V3. Suppose that I current is passing through them. Now the total potential difference will equal to V is equal to sum of these potential difference V1 plus V2 plus V3. Now if I is the current passing through them, R is a resistance, by knowing the Ohm's law V is equal to IR, we can fill the values. Here I is the current, R is for the resistance in series, V1 IR1, V2 IR2, V3 IR3. I will be cancelled out by taking common, so the formula for the resistance in series is R1 plus R2 plus R3. Hope you understand. Now next is a parallel combination. When the cells are said to be grouped in parallel, when the potential difference is same and the current will be different, then the cells are said to be in a parallel combination. Now in this, current is different, then sum of the current will be I1 plus I2 plus I3. Okay, by knowing the Ohm's law V is equal to IR, V is equal to IR, then I will equal to V over R. Okay, so we can write down now resistance are in parallel. Okay, V over RP, V over R1, V over R2, V over R3, where R1, R2, R3 are the resistance. Now taking the value V is common, then we are left with the formula that 1 over RP, that is resistance in parallel, equal to 1 over R1 plus 1 over R2 plus 1 over R3. Okay, so the resistance are said to be in parallel. You will use this formula. Okay, up to n you can utilize this. Okay, hope you understand this. We have discussed today color coding for the carbon resistors and the combination of resistance in series combination and in parallel combination. Okay, subscribe this channel, those who are not subscribed the channel. Okay, and like this video. Thanks.